My name is Sanjay Srivastava. I work for a company called Genpact. I'm the Chief Digital Officer. Genpact's a large global professional services provider for digital transformation for clients we serve in insurance across the globe and a few other industries. And the bulk of the work that I do and my group does is puts together digital transformation for clients in analytics, in automation, in artificial intelligence, and in experience, what we call design thinking, journey mapping, and agile development. I spend 80% of my time with clients, but I do spend some time internally because our company, perhaps very similar to others in this room, has gone through its own digital transformation, and we have transformed from the company we were to the company we are today, and we're on a path to becoming a company that we know we want to be as we progress the transformation journey. And so I have reflections of many journeys, sub-journeys we've had in that. We've made mistakes, we've learned from them, and I think through that we've actually transformed ourselves completely. And I'm happy to open up that part of the discussion as we get into Q&A. I'll be joined for a Q&A with our head for AI and insurance, a gentleman called Ram Shetty, and I can't see him here because the light's in my eyes, but at the right time we'll bring him up. And we'll go through an interactive Q&A session. You know, you've got the app. If you want to just enter questions as we go through that, we'll pick some from there and we'll address them. And if we can't get to all the questions, we'll pick them up later. So with that, let's get started. So today we're going to talk about artificial intelligence in insurance and the whole idea of what is it, where we take it, and what's real today. But before I get started, I must point out that I spend a lot of time with CEOs, CXOs. I've met with about 50 to 100 boards in the last 12 months, and many of the questions that I get from them really come down to one simple thing. What is the role of AI in my enterprise? And a little bit of where that question is coming from is, look, we just went through IoT. And then, by the way, we've moved over to blockchain. And is AI just the next version? Is it the next wave? Is it the next thing I need to do? And then soon I'll be moving on to something else? Or is it something that is more fundamental? Is it something that is more core? And we have a point of view on this, and I want to share that with you very quickly, that we've developed through these interactions.
Nature is survival. Every action and reaction guarantee tomorrow. It understands that uncertainty is certain and change is constant, and relies on instinct to not only survive, but flourish and thrive. The instinct to change as its world changes, sense an obstacle before it becomes one, and harness the power of many. Imagine a business with these same abilities, making better, faster decisions on its own, enabling the full potential of its people, evolving into an instinctive enterprise. Guided by deep industry knowledge and enabled by artificial intelligence, the instinctive enterprise processes and analyzes information instinctively, adapting, predicting, and connecting, with every encounter making it more intelligent. An instinctive enterprise uses domain, industry, and customer knowledge to create adaptive, purpose-driven workforces. It analyzes data to create predictive insights that allow people and systems to act with precision before others can. Its connected ecosystems eliminate silos and fearlessly embrace partnerships for better customer outcomes. With AI as its neural wiring, the instinctive enterprise defines and redefines its world, turning reactors into forecasters, human potential into peak performance, and the unknown into the to-be-conquered. It's time to evolve. It's time to begin the transformation.
Great. Now let's get started. I'll want to start by saying the following thing. We believe AI is fundamental, it is core, it's foundational for enterprises. We don't look at it as yet another innovation in a string of innovations we've gone through. And we think that's important because this notion of instinct and instinctive responses doesn't mean that we think enterprises will act blindly and automatically to every stimulus. But it does mean that as we access an ever-growing, throbbing, pulsating, real dynamic web of information, our ability to synthesize that and be able to drive inferences and react to it is enhanced, it's delivered, it's enabled by artificial intelligence. And in many ways, we think it resembles, if I were to look at a set of data and I could react to it, the challenge with data now is that you need the collective intelligence of many, many, many other people over many years in the past to be able to harness the same instincts. And we think AI is the fundamental neural wiring that delivers that. And we think, by the way, this is a really important question for boards to address because it gets down to foundations of employees and talent strategy and choice of capital investment and areas to start. So if you've been thinking about this question, I think it's a really important question to get right. Now, I'm going to shift gears from sort of where we see this going to where we are today, okay? We do a lot of work in the space, as I said, across analytics, AI, automation, and experience. At any point in time, we have about 400 to 800 of digital transformations that are going at this point in time across the globe, and there are many learnings that we've been able to take from there. And so what I thought I'd do for you today, first, is actually quickly demystify AI and talk to you a little bit about how we think about AI in terms of the possibilities, and then narrow it down to what's real, what's here, what's now, today. And so with that, let me get started with a few examples from the work we're doing within the insurance industry. Now, as a backdrop to AI, I'll tell you that I think about AI as narrow AI, broad AI, and general AI. Narrow AI is AI applied very specifically to one task or one process. Broad AI is an expansion of that. So for instance, if we're doing claims assessment in earthquakes, we would apply a set of narrow AI techniques to them. If we think there's enough in the earthquake area versus the hurricanes area, and so now we've expanded the domain, we think about that as broad AI. And then, of course, all of the discussion in the industry is about general AI, which is resembling common general sense of humans. We think that's very far out, and we don't think that's at play today. So we come back and look at narrow AI, which is where most of the activity is happening today. We think there's some early work that's starting in broad AI, and we don't think general AI is at play for 50 plus years to come. Now, within narrow AI, what we've done is we've taken the entire gamut of technologies and we've broken into 4 segments that I thought might be valuable for you to sort of keep in mind. We think about that as language, conversation, sight, and knowledge. And what I'll do is I'll walk you through these examples. I'll point out how we're using each of those capabilities. Language is about deciphering and understanding intent from a body of written words. Conversation is about intent analysis and holding the threads of a conversation or back and forth to be able to understand that journey and deliver better customer experience. Sight is about computer vision, and we're applying that in many areas, but there's a few areas that it's real and it's here today. And then knowledge, which is how do we capture the domain knowledge that sits across the ecosystem and distill it into an AI system that can augment, that can deliver predictable results. So my first example is from the area of language, and we're going to pick up this topic that we do a lot of work in, which is around submissions. And more broadly, we look at the entire broker, underwriter exchange of information and the process. And we journey map what that looks like, and we understand business results associated with that. And the idea of how do you increase profitability, how do you manage the experience, the back and forth of information in a predictable, manageable, pleasant fashion, and then how do you respond quickly and decisively so you can capture the right business results. So I'll give you a few examples where language or natural language understanding as an AI technique is now at play, and we use it to take incoming submissions. We extract from PDFs and other documents, sometimes through OCR and enhanced OCR, sometimes through PDF and automatic extraction. And then we understand the language to be able to translate that into a set of structured information that can sit in a database. What that ultimately allows us to do is to classify an incoming submission so we can quickly resolve it and respond to it in terms of clearance. The depth of technology gets deeper into things like schedules of values, into the loss rates, and so forth, so we can pull out usable information to help with rates and quotes and be able to price in a decisive fashion. And then we're able to take all of that body of information around the decisions we make in the rate and quote process, and we can apply machine learning to be able to learn from that and drive the algorithms for the future incoming workflow. What we're finding out, and by the way, we are an operator as well, so we do a lot of this work for clients, on behalf of clients, by actually doing it manually. And we've taken some of that learning, and what we're finding is that we're able to take hours and compress it into minutes. And more importantly, we're changing the experience between the underwriter and the broker, and the quality and the ability to tap in the information to make much better decisions. All of this happens because of natural language understanding. It's the ability to take all of the dark data that sits in the enterprises and be able to extract valuable, structured information. The second area, we'll get into a little bit of the conversation, because what's inherent in conversation is the ability to think through 5 or 6 or many more pieces of information and to string it together into a knowledge that can be used. So when we think about claims, and we look at incoming claims intake and incoming claims, we've applied artificial intelligence to be able to read and ingest that information at scale, and then be able to once again think about that information and apply some techniques right off the bat. The first one is actually policy verification. So how do you do the coverage? How do you pull up the right policy document? How do you pick up the right FNOL? And then how do you reconcile them to be able to make sure that this is actually applicable versus not? So once the verification is complete, we take that set of documents and then we put them into the next step around understanding the detail. This is where language becomes very important, and we'll talk a little bit about some of the gotchas and some of the learnings we've had, because there are nuances around the use of language that become very important to be able to factor in. I'll come back and give you an example. But we use that structured information to be able to make decisions on claims coverage, and then we use that to actually extract information relevant to subrogation. There's large opportunities in subrogation that are let go by many of our clients today because it's very difficult humanly to read through all the notes that have come through from a variety of assessors and then be able to pinpoint and pull up subrogation information. Using machine intelligence, we're able to do it much more predictively and much faster. I'll give you a third example, and this is the example in the area of sight. This is work we're doing with a large provider, a global provider of AI as a platform. But we're using that platform and building on top of it a proprietary neural net that does this for us on behalf of our clients. We'd acquired a company that actually has an Uber-like app for assessors that would go out and address automobile damage, as an example. One of the reasons we did this is because there is an underlying base of information, millions of photographs that were taken, and an understanding of the adjustments that came on the back of that. In my world of AI, that's labeled data. Data because you've got photographs, labels because you understand how much it costs to be able to address that damage. And labeled data is the crux of machine intelligence. It's the basis for machine learning. And what we're doing is we're taking that data and running it through artificial intelligence engine so we can design the neural net that can allow us to be able to look at a photograph and give us an estimate. Now, existing capability where we have reached is we can look at a photograph and we can assess, brackets and decisions on tow versus not tow, fully write-off, etc. But that predictability, we think, is going to get, the range is getting narrower and narrower as we feed more machine learning data into it. and will change the nature of this industry, because fundamentally this issue is about experience for the insured. It's about fraud and analytics for what needs to be done. And it's about understanding the cost and managing your book accordingly. And that's what computer vision is allowing us to do in the context of automobile insurance. So I've given you 3 examples. Knowledge is actually the hardest one. And we're early in our journey on knowledge, because ultimately what knowledge does is it captures much of this information that exists and puts it back in. And I'll walk you through why where the challenges are and how to address them. So let's now move into a discussion about, that's great. There's a lot of opportunity. Many of your counterparts, perhaps some of you, are actually deploying this today as we speak and laying the foundation for that instinct that we talked about earlier. But the reality is there are many, many, many bumps on the road. There are many curves down the path, and it's important to be able to tell and be able to plan on that. So I wanted to share with you some of the learnings we've had as we've hit these roadblocks in our pursuit of artificial intelligence over the last 3 years and applying it towards insurance, in the hopes that that might actually engage us in a good discussion. And I'd love to hear other questions you have and at least give you a perspective for how we go about it. I'll probably put out 4 big challenges that you want to be thoughtful of as you're thinking about applying AI in your enterprise. The first one is this notion of explainable AI. And if you haven't sort of thought about that deeply, the idea is very simple. Most AI today comes across as a black box. Here's how it happens. You put in the question, you've got the answer. Don't ask how or why, trust it. The challenge is black boxes don't work. They don't work in any regulated industries to start with, so regulators are always loath to be supporting these sorts of things. But actually, when you get past that, even if you think about adoption, which is one of the larger drivers of success for AI, the reality is if we don't understand how a decision got made, you're not going to trust it, and it's not going to get adopted, and you're not going to get the return on the investments you make as we go along. And we realized and stumbled, actually we ran into this problem with no foresight or understanding, and then stumbled our way through it, and I think we found a way to solve for it, which I'll share with you. Now, bear in mind, the problem is inherent to AI, because if you think about artificial intelligence, the reason it's so fantastic and such a large opportunity is the design principle of AI is different from the design principle of software programming. All of the automation we've done so far is all based on a very simple principle, what if then? And as long as you know all of the whats, and you know all of the ifs, and figure out what the thens, then you can actually program it to do it much faster, much quicker, much more reliably than you can yourself. And that's what computer programming has been for the last 30 plus years. Artificial intelligence actually breaks that paradigm, and it says, look, I'm not going to tell the program what if then. In fact, the only thing we'll do is we'll give them the problem, and we'll give them the answers. And we'll give it hundreds of times and thousands of times and millions of times. And we want the AI program to figure out for itself the next time I give the problem, what the answer is. And so in many ways, AI breaks the paradigm of how software programming is done and fundamentally actually changes the game. And it's that very reason why it's so potent as a tool that we use in. But with that potency comes the downside, which is it is a black box. If you look at the neural nets that are constructed on vision, there is no way as a human being you can correlate those nets, those neural footprints, and be able to derive a conclusion. Much in the same way, if I, instead of seeing this room, only looked at the neural impulses that are in the synapses that are going through my brain, and that's the only view I had, I'd never be able to construct the image of this room. So it's the same problem. And so AI is fundamentally difficult in that regard. So the way we've solved for it is we have put traceability in atomic components. And so here's what I mean by that. So for instance, we do a lot of work for finance, and we will take large books of balance sheets. So let's say we take 5,000 balance sheets, we run it through our AI engine, and we're able to figure out the risk for each company that's represented by a balance sheet. We're able to then aggregate it, and we can put a risk on that portfolio. And we do this every day, day in, day out. We've done this for the last few years now. for large financial services companies across the globe. Now, the only reason this works is because when you look at that page on the screen and you see a number and you don't like it, you have the ability to click on it. And you click and you drill down to the subcomponent of the numbers that added up to that derivative number. You look at the third number and you say, well, actually, that doesn't feel right. You click on it, and now you can break it down to the numbers that actually rolled off from one of those balance sheets. You take the seventh number on that balance sheet and say, that's not right. You click on it, you actually go to page 19, footnote number 2. Here's the 3 sentences that were extracted that gave me that one number that added up to this other number, that aggregated to this number, that we reported as this number. And this ability to click and drill, to track back to an atomic piece of information that gave rise to that is one of the things we were able to institutionalize. And I think as a result of that, we've been able to deploy AI in an area that is highly regulated and is highly crucial for our clients in basically risk management. And so I offer that up, which is, it isn't AI, it's how you put AI to work and how do you make it granular and trackable and click and drillable that addresses that. And that's been a learning we've had as we've gone through our journey that might be worth replicating if you run into this problem. The second problem that you will most likely run into, in fact, I can pretty much guarantee you're going to run into this problem, is low data density. And what do I mean by that? So we're all used to AI with our Siris and our Alexa and AdWords and click-through. But what's really behind that is large streams of data from which you can machine learn and make decisions. And so if millions and millions and millions of times you say this and you mean that, the machine will learn it over time. The challenge in most businesses is you don't have that size of an information database. We'll deal typically with 5,000 incidents, with 50,000 policies, with 100,000 contracts. We're not dealing with hundreds of millions of those terms. And so the ability to use some capabilities like the Chicago parser or the Stanford parser, which actually works fantastically in many other areas of AI, actually completely breaks down and broke down for us when we applied it in financial services, because you just didn't have the ontology and the database and the machine learning from the information that was large enough. And so you've got really low data density in the parlance of AI. This problem is most likely to come up if any of you apply this in an enterprise. And I want to tell you the things that we did to get around this a few years ago when we stumbled into this problem unintentionally. And the key for us was understanding that not all AI is created equal. There are some capabilities that are really good for these kinds of problems. There are other capabilities that are really good for these kinds of problems. I'll give you an example. When we use Chicago parser, when we use Stanford parser in a normal natural language conversation, it is very easy for us to understand where that conversation is going. The challenge is that when you don't have enough intelligence built in, you have to approach the problem differently. And what we did is, we said instead of using mathematical parsing, which is what Stanford does, which is what some of the best engines in the world do, you say red, apple is red, I had a red fruit, was an apple, love the color on it because it's the shade of red, and da-da-da-da-da, and millions of times over, it'll finally figure out that apples are red. When you don't have that math, when you don't have that volume, when you don't have that density of data, then we've stumbled upon another way to approach it, which is using computational linguistics, which is instead of using mathematical computations, we said, how does a child learn language? How do you take a sentence? How do you break it into its parts? How do you disaggregate the grammar from the nouns and the words? How do you then be able to understand what each means? And then how do you aggregate them back to be able to resemble the knowledge that was inherent in the sentence? And that's an important capability to have. Otherwise, you're not able to tackle the problem that we ran into with low data density. And I think the thing I would leave you with is, as you approach problems in AI, be thoughtful about the set of choices you have in front of you. Not all choices are created equally. Don't pick the first one that just comes up, and give some thoughtful design thinking around which tool you want to apply to which problem in the world of AI. The third problem you will, it's not the first set of problems you'll run into, but you'll eventually run this in your journey. We ran into it, and it's the problem of knowledge and how do you capture it. So I'll give you a very simple example. We won't even go off this page, and I'll come back to it. You know, think about this. An 8-year-old comes back from school and tells his mother that I'm really unhappy and the world is very unfair because Ben pushed me, I fell on the ground, I got up and I pushed him back. The teacher didn't see him pushing me, but she saw me push him. So I got detention, he got to go home. This is really unfair. The reality is any 8-year-old in the world, doesn't matter what language, hopefully we can get through that, will know exactly what I just said. They'll know that like that. No AI system can figure it out today because we don't have a sense of causality. We don't have a sense of equity and fairness. We don't have actually even a good sense of the time series. This happened before that, and that caused as a result of this, right? All of that isn't captured yet. And what's happening is, you know, I can take out my cell phone and say, where's the nearest Starbucks? And I'm going to get a very accurate response. But if I called it in and said, you know, I want to understand this one policy on page 19, it says this, that, and the other, and I wanted to check on something else, there's no knowledge microservices. There's no rich data graphs that exist today that can address that. And so be thoughtful about that as you get into it, because you're not going to find those rich knowledge graphs. We didn't. And what we've had to do is to actually take domain experts, people that come from the world of insurance, and in our case, other businesses, and AI experts, machine learning experts, and put them together. So every interaction we do, we're capturing the knowledge, and we're actually building it into a knowledge microservice. We're resembling this into a richer knowledge graph. We're putting in the same format that your Alexa uses to call an Uber when it ordered. It needs to get into the same level of depth of understanding. And that's a bigger problem to solve. It's not going to be the first one you'll hit, but if you do develop AI deeply in your enterprise, I will guarantee this problem will come up. And when it does, you know, you want to think about how you mix domain. How do you take process understanding? How do you take an understanding and the distillation and goal orientation of the environment and then mix it with data science? Data scientists, artificial intelligence by itself will not be able to solve this problem. We've designed a term within the company, and I think we're starting to get very bullish on this term. We call it bilinguals. And it denotes a talent category in our world, which is an intersection of two languages. And we've actually gone out and been very clear on it. So we said, we don't need someone who is 10 on 10 in English. Frankly, we don't need anyone who's 10 on 10 on German. But what we need is someone who understands French, German, and can translate back and forth. And this notion of bilinguality, this notion of being able to understand artificial intelligence and understand insurance or claims or subrogation, and being able to converse at that level has been really key. And so be thoughtful about that as you think about our talent strategies. We're an 80,000 employee company, so we've had to spend a lot of time thinking about what AI means for our enterprise. What does it mean for our employees? As work of the future comes to be what it will inevitably come to be, what does it mean for our people, and how do we actually give them the skill sets and the transition to actually to go with us on the journey we're on. And there's a whole other discussion we can have on that, because that has had its own set of opportunities and challenges. I actually think in hindsight we've done a fantastic job on it, but there have been many learnings of the way. And talent in AI is one of the hardest things to solve. There aren't enough people in the industry. There aren't enough one language people, at least in AI, that you can hire, even if you wanted to. And thinking and reflecting on how you take your existing employee team and cross-sell them to be these bilinguals is a really important part of your strategy. It's a different discussion, but it's important to sort of keep that in mind. Okay, so the fourth, and perhaps in hindsight, one of the biggest issues we've come across with clients is that we've realized artificial intelligence and transformation on the back of it is not a destination, it is a journey. We didn't think that way when we started. We said, wow, we've got this thing project, we're going to go, and the client wants to do this, we'll go implement this. And here's an opportunity to take the work we do through AI, let's go do that. And they were always end destinations. This is what we want to do here. This is what we want to do here. A few years into the journey, I have come to realize that that's not the case. And I'll tell you a day in my life over, let's say, 3 different points in the span of 1 year. On day one, I'll be in a meeting with the CIO of a large corporation, and the discussion at the table is, look, Sanjay, we need to do robotic process automation. We can put so much productivity, but can you deploy 1,200 robots in the next 6 months, starting in Copenhagen? And we're off on this mad dash trying to figure out how do we get talent in the city, on location. Many times we can, frankly, many times we can't, but the process for the client goes on. What's interesting, though, is they'll do this, and then fast forward 6 months, a day in the life, here's the second conversation. Well, geez, I didn't realize that we actually have all this data, because now we've taken some of these processes we were doing manually, and we've put it into this robotic process automation tool, and now all of that is digitized. So can you guys go off and run some machine learning? Because I'd like to understand, what are the patterns in that data? What are we learning from that we haven't learned, but now we are in a position to do that? So we'll run off, so we did the first process with some $15 million startup with the robotic process automation software, and kind of did all this automation. And then now we have to do machine learning. Now we have to turn to TensorFlow or Google or someone else. And now we're actually applying that and using their capability to build out a knowledge base that allows us to come to patterns. And by the way, if by chance we end up in a scenario, 6 months fast forward, here's what happens, right? We actually do have some patterns. We actually do have some information that's insights that we've now captured because all this data is now available for the first time. The conversation inevitably is, well, geez, can you put a conversational AI chatbot on the front end of those patterns and the data and the insights you picked up? Because I want our vendors or suppliers to be able to self-query and get responses, as opposed to running it through our employee teams. If you reflect on that journey, here's what's really happened. What started as a simple robotic process automation with this piece of technology has matured into a machine learning with that piece of technology, which has gone into now conversational AI with Lex or Poly or some other piece of technology. And the challenge is, as you traverse this journey, how do you leverage the investments you made here with the advances you made in the next step, and then take it to where you're eventually going? It is a journey. It is not a destination. And this mindset of planning for the journey becomes really important. And what we've done to be on that journey is implemented a digital business platform. Now, ours is called Cora, but then many will design it themselves, and others may be available as well. Our thinking on Cora was to do the following. We took our 4 areas of work. We looked at artificial intelligence, we looked at automation, which was in the example I just gave you, we looked at analytics, and then we looked at experience. And we've curated it down to a few technologies in each of those areas. The curation is ours. It's based on our practical experience of what works, what doesn't work. It's what we use in play. We think this may be slightly different for you, and we think this will expand over a period in time, but it's true for the work we do today. And what we're really trying to do is take these different technologies and weave them together into a service orchestration methodology. Put a governance engine around it so you can manage which bots are up, which bots are down. And then be able to integrate and roadmap the different stops so all of them are on one service architecture. All of the work we do here is fully leveraged into the next step, next step, and next step. Our version of this is called Genpact Cora. We've been very successful applying it. It may be interesting for you to look at Genpact Cora, and even if it isn't, I would encourage that you think about journeys, not destinations. You think about the stops you're going to have on the way, and you give some thought to how do you integrate those stops in a manner that you can protect your investment across that journey. You don't want to end up in the situation that one of our clients, and we did RPA, and we did something else in machine learning, we did something else in conversational AI, and actually with them, we're now pursuing something with knowledge as well. So 4 just practical examples of problems, of challenges, of issues, and yet opportunities and solutions and approaches that have worked for us that I wanted to share with you. So you had that. And with that, I guess I want to quickly summarize. I can't see my screen up here, so I'll say, here are the lessons that if you had to walk away. Number 1, black boxes don't work, so think about explainable AI and design that up front. Not all AI is created equal, so think about it as a set of tools, and you have to pick the right one from that toolkit to apply to the right job. Design with the end in the sight, and think about a platform that allows you to get there. And then I didn't spend time on the last one, but the core in the end of this is talent and a foundational platform. And really make sure you've got a plan for that and get it right.